Hello and welcome. In today's class, we'll be solving a KMap problem. And this KMap question is taken from the ISC Sample Question Paper 2024. So the question is that we have to reduce the Boolean function f with variables a, b, c, and d. And when we see this pi symbol, alright, so when you notice this pi symbol, it means that we have to reduce it in POS, product of sums. And these are the numbers given, the max terms. By using 4-variable KMap, showing the various groups, octal, quads, pairs, etc. So we have to draw the KMap first of all. And this is the KMap. And we have put zeros in those max terms. 0, 1, 2, 3, 4, then 6, 9, 11, and 13. Remember that in POS expression, we select the zeros. That's why we are writing zeros in these numbers. Another difference that you will see between POS and SOP is that when we are writing all the combinations of these variables, like here we have different combinations of A plus B. And similarly here we have different combinations for C plus D. Here 1 is written in complemented form and 0 is written in non-complemented form. So A plus B, this is actually 0 plus 0. A plus B naught, this is actually 0 plus 1. Then this one is 1 comma 1 and then 1 comma 0. So this is how we are going to draw the KMap. Once our KMap is ready, we have to do the grouping. So if you look at these 4 boxes, which are highlighted. So these 4 boxes form a quad. Octals are not possible here in this diagram, but quads are possible. So this is one of the quads. Because when you do map rolling, okay, so you want to join the top edge with the bottom edge, then these 4 zeros will form a quad. So we are writing it in POS form, product of sums, and then we are reducing it to B plus D naught, because B is one such variable which is not changing in any of these terms. Similarly, D naught is one such variable which doesn't change in all of these terms. So how I generated these terms. So when you look at this box, the first box, so A plus B, it is in A plus B row and C plus D naught column. So that's why A plus B plus C plus D naught. Then this 0, A plus B plus C naught plus D naught. And that's what we have written here. So this is how all the boxes are written down as different terms of the POS. And then we know that when we have a quad helps us to remove 2 variables. And that's why when we reduce it, we have only 2 variables left after removing 2 variables from these 4 variables in each term. And why we got B and D naught? As I said, B is one variable which always remains as B in all the terms. So we select B, and same with D naught. D naught is not changing. D naught remains the same. Next, we have one more quad. So if you try to do map rolling sideways, so if you try to join the left edge with the right edge by rolling the map, imagining that you are rolling the map, then these 4 boxes will again form another quad. And now we are reducing this quad. So same way we have written again all the terms of the POS expression, and then we see that A is a variable here which is not changing, D is another variable which is not changing, and so we only write A plus D. B is changing because see, B is here without complement, but if you look at the third term, it has become B naught. That's why we are not taking B. And same with C. C is also changing, so we are not taking C. So quad always removes 2 variables, and that's why we are now left with 2 variables here also. And then we have a pair. A pair only removes 1 variable. That's why when we write down these terms for the pair, we see that only B is 1 variable which is changing. Otherwise, A naught remains the same, C remains the same, and D naught remains the same. And that's why this is the reduced pair value. And that's all. These are the groups that are formed. So based on this, this is our reduced POS expression. A plus D, B plus D naught, A naught plus C plus D naught. So all of these terms are ANDed together. So the first part of the question is solved. Next, we have to draw the logic gate diagram for this reduced expression, assuming that the variables and their complements are available as inputs. So this is our diagram. You can see we have used OR gates for the plus sign, and for the multiplication sign or the AND sign, this is the symbol. So finally, all of these terms are ANDed together. That's why we have used AND. And because in the question it was mentioned that you have to assume that the variables are available both in complemented and uncomplemented form. That's why I'm directly taking D naught as my input, and I didn't have to use a NOT gate. So A plus D, B plus D naught, and A naught plus C plus D naught. And then these outputs are sent to this AND gate. And because of that, all of these values are ANDed together, and this is our final result. And the second part of the problem is also solved. So that's all for today. I hope you have understood how to solve these KMap questions. Thank you for watching. If you still have any doubts or questions, you can always get in touch with me through comments. Thank you once again, and see you in the next class.